Here we are about to start set 4. This is set 4 of year and subset 1 of set 4 of year 2023. And we are about to start with the section 1, which has multiple choice questions of 1 marks each. And the first question is about the matrices. So x into the matrix 1, 2 that has elements is equal to this. We have to find the value of choose the correct option here. So let's multiply this. This is x and 2x. Okay, and now multiply with y, which gives me 2y, and this is 5y. This is equal to 4 by 9, and 4 and 9. Okay, now x plus 2y is, this is x plus 2y, and this is 2x plus 5y in the matrix if we add them, which gives us 4 by 9. So these matrices are equal. That means their corresponding elements are also equal. So we have the equation x plus 2y is equal to 4 and 2x plus 5y is equal to 9. And then let's multiply the first equation with 2. So multiply this equation with 2, which gives me 2x plus 4y is equal to 8. And let's subtract it from the second equation, which was 2x plus 5y is equal to 9. If we subtract this, which gives me negative y is equal to negative 1. So y is equal to 1. And if y is equal to 1, if I use the first equation for y is equal to 1, so x plus 2 into 1 is equal to 4, which gives me x is equal to 2. So x is equal to 2 and y is equal to 1. So B is the correct option for this. Okay, for second question, we have to find the product and we have to choose the correct option. So product of these matrices, R matrices has the elements. The first one is AB, negative BA. This is the first matrix and it has to be multiplied with the second matrix. So A, negative B, and B and A. All right. So to find the product, we are going to find the sum of the product of the respective elements and the columns. So that is, we have to multiply A with A. So this is A into A plus B into B. This is the first element. And now use the second first row with the second column. So A into negative B is negative AB plus AB, which is 0. Now use the second row with the first column. So negative AB plus AB, and use the second row with the second column. So this is B square, B negative B into negative B is B square plus A square. And so this is now equal to A square plus B square. This is 0. This is also 0. And A square plus B square. So our option among these is the option A. So A is the correct answer for this one for question number 2. Okay, for question number 3, we have A is a square matrix and A square is equal to A. Then what is the value of this? So we have to value of the expression identity matrix plus A the whole square negative of B into A. So let's use an identity here, A plus B the whole square, which gives us A square, which is I square plus B square plus 2 into A into B negative 3A. Now the square of the identity matrix is the identity matrix itself. A square, it's given it's A, and 2 identity matrix into A will give us A minus 3A. So this is equal to identity matrix plus A plus 2A is 3A minus 3A. This gets cancelled and we are left with the entry matrix. So A is the answer for this one. Okay, for question number 4, it's given that A is a matrix that has a single row and the three columns. So its order is 1 by 3. M into N, where M are the rows and N are the columns. And A transpose A, we have to find the matrix A into A transpose, where A is the transpose. The transpose of this matrix is 1, 2, 3, and it has three rows and one column. So we have to find the product of A and A transpose. So this is 1, 2, 3, and 1, 2, 3. So let's find out the product. So that would be a single element. So this is 1 into 1 plus 2 into 2 plus 3 into 3. This will be the resulting matrix. So 1 into 1 plus 4 plus 9, which will give us 14. So 14 is the matrix. So answer is option D. Okay, for next question, we have to find the value of the determinant. We could use the properties of the determinants because, and now it's not in the syllabus, we will just use, you can use any of the row or the column to evaluate this determinant. Let's use the first, I'm going to use the first row. So let me assign the sign positive, negative, and positive. And how do you evaluate this? So this is x plus y into determinant. Remove the row and the column for x plus y, which gives me x, y, 1, 1, and then negative y plus z. I'm expanding along R1. So remove the row and the column for y plus z. So if I remove the row and the column for y plus z, I'm left with uh, the determinant zy and 1, 1. And the last one is plus z plus x. And if I remove the row and the column for the z plus x, I'm left with zx and 1, 1. Okay, now, and this is x plus y into, multiply this and subtract this product. So x minus y, then it's negative y plus z, and then it's z minus y plus z plus x, and then it's z minus x. Okay, this becomes x square minus y square, and this is z square. This is a square minus b square, and this is also a square minus b square. Okay, so this gets cancelled, and if I open up the bracket, so we are left with minus z square plus y square plus z square. This gets cancelled, this gets cancelled, and the answer is 0. So 0 means that A is the correct answer for this. Okay, for next question, we have to check where this function, modulus function, is continuous and differential everywhere, continuous and differential nowhere. We have to choose the correct one. So f of x is equal to modulus x. We know that the value is it's x when x is greater than equal to 0 and negative x when x is less than 0. So clearly this function, if I plot it on the number line, so if I take this as 0, so greater than 0 has the value x and less than has negative x. So this function is continuous everywhere because we have this being you can say the polynomial function. So it's continuous everywhere, but it's not, and it's also differentiable everywhere except when the value is 0. So at 0, this is not differentiable, and so this is continuous everywhere, but differentiable everywhere except at 0. At 0, this is not differentiable. So our option is option C. Okay, for question number 7, it's given that y is equal to sine square x cubed, then what is the value of its differentiation? So our function is y is equal to sine square x cube, and let's differentiate it. So dy by dx is equal to, we are first going to use x raised power n. So this is n into x raised power n minus 1. 2 minus 1 is 1, so x cube, and then the differentiation of sine, which is which will be cos of x cubed, and then the differentiation of x cubed, which is 3x squared. So finally, I can write it as 3 to the is 6x squared into sine of x cubed into cos of x cubed. So which is option C. So C is the correct answer for this one. Okay, for question number 8, we have to find the integration of. So let's find out the integration of e raised power 5 log x to dx. Okay, now e raised power 5 log x, I can write it as, let's say this is integration I. So I can write this as, this is of the form m log n, which is equal to log n raised power m. So this can be written as log e raised power log x raised power 5. Okay. Now we know that if it is of the form e raised power log x, then this is equal to x. So I can write this as, so this becomes integration of x, instead of x, we have x raised power 5 into dx. Now it's easier to integrate x raised power 6. We can use the formula x raised power n plus 1. So this becomes x raised power 6 plus 6. So this is our integration, which is option B. So B is the correct answer for this one. Okay, for next question, it's there is an equation that the integration of 3x squared, that's a definite integral, is equal to 8, and we have to find the value of 8. So this is 0 to a, and this is 3x squared into dx is equal to 8. And let's take 3 out. So integration of x squared would be x cubed by 3. And let's evaluate for the limit 0 to a, which is equal to 8. So 3, if taken out, this is 3 divided by 3, and it's x cubed is 0, but to a is equal to 8. This is now 1. So evaluating it for a and limit 0, this is a cubed minus 0, which is equal to 8. So a cubed is equal to 8. So a is cubic root of 8, which is equal to 2. So a is equal to 2, which is the first option A. Okay, for question number 10, we have to find the integrating factor for the differential equation. And our differential equation is x into dy by dx minus y is equal to 2x squared. So to find the integrating factor, let's get into the standard linear differential equation form, which is dy by dx plus py is equal to q. And to get this into this form, I'm going to divide each and every term by x, which gives me y by x, and this is 2x. So if I compare these two equations, our p is negative 1 by x, and q is equal to 2x. But we have to find only the integrating factor. So integrating factor is given by e raised power p into dx, which is equal to e raised power p is negative 1 by x into dx, which becomes negative is out, and this is log x. And I can write it as e raised power log x raised power negative 1. So negative 1 is 1 by x, and now this becomes 1 by x. So 1 by x is the answer, which is the option D, 1 by x. Okay, for question number 11, we have to find the order and degree if defined of the differential equation. So this is not a valid differential equation, because sine of dy by dx, this must be the angle here. So differentiation is not possible here. So this is not a valid differential equation, but because this is differentiated for the maximum order 2. So the maximum number of times it's differentiated is 2. So the order is 2. We can write down the order. So order is defined, but because it's not a valid differential equation, so the degree is not defined. So degree is not defined, which will help us to choose the option D. So D, that means order is 2 and degree is not defined. Okay, for question number 12, we have to find the unit vector along the vector. The vector is 4 cap minus 3 cap. So we have to find a unit vector along this vector. So let's say in this vector, let's assume this vector as a vector. So a vector is 4 cap minus 3 cap, and unit vector is given by a cap, and the formula is a vector divided by its magnitude. So let's find out the magnitude of a vector, and the magnitude of a vector is the sum of the square of the scalar components, and 4 square is 16 plus 9, which is 25. So this is 5. So that means a cap is a vector, that is 4 cap minus 3 cap divided by 1 by 5. So which is the option B. Okay, for question number 13, it's given that if theta is the angle between two vectors A and B, then the dot product is greater than equal to 0 only when we have to choose out of these four options, any one. So we know that the dot product of any two vectors is given by the magnitude of A into magnitude of B into cos theta. Now, the magnitude of A will always be positive. This will always be positive because we know that the magnitude of any vector is given by the sum of the square of the scalar components. If A vector is let's say xi cap plus yj cap plus zk cap. So this will always be positive. This is positive. Now this has to be greater than equal to 0 for the dot product to be greater than equal to 0. So cos theta should be greater than equal to 0. Now cos theta is greater than equal to 0 in the first quadrant, that is cos 0 is 1 and cos 90 is 0. So that means theta should be greater than equal to 0 and less than equal to pi by 2, which gives us the option B to choose. For question number 14, we have to find the distance of the point PQR from y-axis. So let's say these are the three coordinate axes x, y, and z, and let there be a point PQR in the space. So this is, let's say, y-axis, this is x, and this is z. This is the origin with the coordinates 0, 0, 0, and let's say this is the point P with coordinates PQR. Now its distance from the y-axis would be the perpendicular distance from the y-axis. So its distance from y-axis would be the perpendicular distance. And this is the foot of the perpendicular and it lies on the y-axis, and we know that the coordinates on the y-axis are of the form 0, y, 0. So if we have to find the distance of this point from the y-axis, it would be py distance. So that means we have to find py distance. And to find py distance, we can use the distance formula, but for that we need to know the value of y. So now the direction ratios of y-axis, or let's say the direction, if we have to find out the direction ratios of y-axis, so that would be, this is x2, y2, z2, and this is x1, y1, z1. And we know that if a line passes through 2 points, then direction ratios are of the form x2 minus x1, comma, y2 minus y1, and z2 minus z1. So that means the direction ratios of y-axis. So we have the direction ratios of y-axis as that x2 minus x1, this is 0, y2 minus y1, which is negative y, and 0 minus 0 is 0. So these are the direction ratios of y-axis. Now we have to find the, now let's say, let's also find out the direction ratios of py using the same formula. So this is p minus 0, p and q minus y and then r. Now this y-axis is perpendicular to py. That means the sum of the product of the direction ratios should be equal to 0. These are the direction ratios A1, B1, C1, and these are the direction ratios A2, B2, and C2. So this is 0 into P plus negative Y into Q minus Y plus 0 into C2, which is R, is equal to 0, which gives us, so Y is equal to Q. Right. So Y is equal to Q, and now we can find out Py using the distance formula. P minus 0 the whole square plus Q minus Q the whole square plus, this is R minus 0 the whole square, which gives us Py is equal to P square plus R square. And this is the perpendicular distance, which gives us the option D. Okay, for question number 15, we have to find the solution set of the inequation. And to find the solution set of the inequation, let's uh, find the coordinates x and y. So if I put x is equal to 0, which gives me y as 7 by 5. If I put y is equal to 0, which gives me x as 7 by 3. Okay, now to let's draw it in the Cartesian plane. So this is the Cartesian plane. Okay, so 7 by 5 means this is x-axis and y-axis. Let's plot the first point. 7 by 5 should be it's 0.4. So the point is 0 comma 1.4. So let's say this is somewhere on the x-axis. Let's say here is the point which is 0 comma 7 by 5, and 7 by 3 comma 0 should be somewhere on the x-axis. So let's say this is 7 by 3 comma 0. Now this inequation is 3x plus 5y is less than 0. So that means we have to draw, the solution region does not contain the points on the uh, line 3x plus 5y. So this should be a dotted line. So this is the dotted line because the inequality is 3x plus 5y less than 7. Had it been 3x plus 5y less than equal to 7, then the solution region would contain the points on this line as well. And this is the equation of the line 3x plus 5y is equal to 7. Okay, so because it's less than 7, so that means the solution region will not contain the points on this line. Okay, now let's try to check this inequation for 0 comma 0. And if I put x and y 0, which gives me 0 is less than 7, which is true. So that means the solution region is towards the origin, that is, it includes the origin, but it does not contain the points on the line. So we have the option here, open half plane containing the origin except the points of line 3x plus 5y is equal to 7. So C is the correct option for this one. For question number 16, which of the following points satisfies both the inequations? And the inequations are 2x plus y. First one is 2x plus y is less than equal to 10. And the second is x plus 2y is greater than equal to 8. So let's check it for the point. First one, minus 2 comma 4. So if I put the values of x and y in this, which gives me this is 2 into negative 2 plus 4 less than equal to 8. So minus 4 plus 4 is less than equal to 10, which is 0 is less than equal to 10 is true. Now for the second equation, it's minus 2 plus 2 into 4 is greater than equal to 8, which is minus 2 plus 8 is greater than equal to 8. 6 is greater than equal to 8 is false. So that means this will not satisfy these two conditions. Let's check the second point, which is 3 comma 2. So if I put 3 comma 2 in the first equation, which gives me 2 into 3 plus 2 is less than equal to 10. So 6 plus 2 is 8 is less than equal to 10, which is true. And let's take it for the second equation. So 3 plus 2 into 2 is greater than equal to 8. So 7 is greater than equal to 8, which is false. So that means this is also not satisfying the given equations. Let's check minus 5 comma 6 for this one. So 2 into negative 5 plus 6 is less than equal to 8. Negative 10 plus 6 is less than equal to 8, which is negative 4 is less than equal to 10, which is true. Okay, for the second equation, it's negative 5 plus 2 into 6 is greater than equal to 8. So negative 5 plus 12 is greater than equal to 8. 7 is greater than equal to 8, which is false. So we are only left with the last one, which will satisfy these equations. So our option is option D, 4 comma 2. Okay, for question number 17, the direction cosines of a line are given. So these are the direction cosines of a line, 1 by A, 1 by A, and let these direction cosines be LMN. And we know that the sum of the square of the direction cosines is equal to 1, which gives me 1 by A square plus 1 by A square plus 1 by A square is equal to 1. And this is now A square. 1 plus 1 plus 1 is equal to 1, which gives me 3 by A square is equal to 1. So if 3 by A square is equal to 1, so A square is equal to 3, so A is equal to plus minus root 3. So D is the correct option for this one. Ready for question number 18. It's given that probability of A speaking the truth is for 4 by 5. So this is probability of A speaking truth is 4 by 5. And let's also find out its probability of A not speaking truth, which is equal to 1 minus 4 by 5, which will give us 1 by 5. And that of B speaking the truth. So probability of B speaking truth is 3 by 4, and probability of B not speaking truth is 1 minus 3 by 4, which is 1 by 4. Now we have to find the probability that they contradict each other. So probability that they they contradict each other is when uh, A speaks the truth and B contradicts that it's not the truth, or when A lies and B contradicts by saying the truth. So that is the case That is a probability when they will contradict each other. So, so probability, or we can also write it as, I can write it as probability of A does not speak the truth and B speaks the truth. So that is the case when they will contradict each other for this one. So probability of A speaking the truth and B not speaking the truth plus probability of A not speaking the truth into probability of B speaking the truth. So let's put in the respective values, which is 4 by 5 into 1 by 4 plus 1 by 5 into 3 by 4, which gives me 4 by 20 plus 3 by 20, that is equal to 7 by 20. So probability that they will contact each other is 7 by 20, which is the option A. Okay, for question number 19, which is assertion and the reason based, and assertion says that all trigonometric functions have their inverses over their respective domains, which fall because the inverses are in the restricted domains. Let me show you how. So the function is trigonometric function is invertible function when it is 1 1 and 1. Now in the domain we have the angles, and in the codomain we have the values here. So now function is, let's say, we know that minus pi by 2 to pi by 2 if we have this domain. So this function is invertible for, let's say, minus 1 to 1. So that means we have restricted the codomain. So this is the restricted codomain. Here are the angles, minus pi by 2, pi by 2, and here are the, this is the codomain. So this is the domain and this is the codomain. So trigonometric functions have their inverses, that is, they are 1, 1 and on 2 over the respective domains, which is not true. It's have the inverses over the restricted domains. So assertion is false. Now the inverse of tan and inverse exists for some x when x is a real number, which is true. So that means A is false and the reason is true, which is the option D. Okay, for question number 20, which is also the assertion in the reason based, and it says that lines are that the first one that has the vector equation and the second one, the vector equation are perpendicular when their parallel vectors dot product is zero. That is when their parallel vectors are also perpendicular. And the reason for this is given by this, where we have to find the angle. So let's use this and see if it's the correct reason to get B1 dot product of B1 and B2. So cos theta is B1 and B2. This is the magnitude of B1 into magnitude of B1. Now let's say B1 is perpendicular to B2. So that means these two lines are perpendicular, so that means their dot product is zero. So when their dot product is zero, so we get cos theta is equal to pi by 2. So cos theta is equal to pi by 2. So cos theta is equal to 0. Sorry. So cos theta is 0 when, so theta 0 means it's cos pi by 2. That means theta is equal to pi by 2. That means that the lines are perpendicular. So the lines are perpendicular when we have assumed that the dot product of the parallel vectors is 0. So that means this is true and this is also true, and this is the correct explanation of A. So you can check the option. The correct option for this one should be A. Both assertion A and reason are true, and R is the correct explanation of assertion A. So A is the correct option for this one. Both assertion A and reason are true, and reason R is the correct explanation of assertion A. So this has the option A. Okay, for question number 21, part A, we have to find the domain of y is equal to sine inverse x square minus 4. And this is part A. So we know that when y is equal to sine inverse x, then the domain is then our domain is -1 domain. That is x is greater than equal to -1 but less than equal to 1. Similarly, in this case, the domain remains the same, so it's the sine inverse function. So here y is sine inverse x squared minus 4. So domain is that is x squared minus 4 should be greater than equal to -1 but less than equal to 1. Now, which gives me this becomes 3 and x squared it becomes 5. So if I remove the square and take the modulus, that is a positive value of x, that should be somewhat like this. So modulus of x should be greater than root 3 and less than equal to root 5. Okay, what does this mean? So when modulus of x is greater than equal to root 3 means that, so let's draw the number line, and modulus of x when it's less than root 3, and let's say this is the negative root 3. Okay, so this is the case when x is less than equal to, so when x is less than equal to negative root 3. So less than equal to negative root 3 means, let's say we have this here -4. So modulus of -4 is equal to root 4, which should be uh, which is the positive value. So x square modulus of x is greater than equal to 3. This is greater than equal to root 3, or x is greater than equal to 3, greater than equal to root 3. So because when x is greater than equal to root 3, let's say when it's root 4, so modulus of root 4 is root 4, and this root 4 would be greater than equal to root 3. Okay, now for modulus of x is less than equal to root 5. So in this case, this would be the case when x is greater than equal to negative root 5, or when x is less than equal to root 5, because the modulus of negative root 5 is equal to root 5, and root 5 would be less than x, less than or equal to root 5. Now, when x is greater than equal to root 5, this value would be, so this is the case, these are the cases when x is greater than equal to negative root 3, and or x is greater than equal to root 3. And when for modulus of x is less than equal to root 5, x should be greater than equal to negative root 5, or x should be less than equal to root 5. And if we plot this on the number line, so this is, let's say, negative root 3, here is negative root 5, here is root 3 and root 5. So for the first one, when x is greater than equal to negative root 3 is this region. Okay, and x is greater than equal to root 3 is this region. And for x is greater than equal to negative 5 is this region. and x is less than equal to root 5 would be so in both regions. So if we check, so we have the common region, we got the common region as this one. So for less than equal to negative root 3, this is the region. X is greater than equal to root 3, this is the region. And x is greater than equal to negative root 5, and greater than equal to negative root 5 is the region. And x is less than equal to root 5 is this region. And we have the common region. We are getting the common region as this. So this is the domain is the union of these two regions. So we can say that our here domain here would be the union of these intervals negative 5 to negative root 3 and its union with root 3 and root 5. The domain is, and these we can also include values as well. So let these be the closed intervals negative root 5 to negative root 3 or root 3 to root 5. So this is the domain union of negative root 5 to negative root 3 and into root 5. For question number 21, part B, this is the part B of question number 21, and we have to evaluate this cos inverse. So we are given that it's cos inverse cos of negative 7 pi by 3, and we know that cos of negative x is equal to cos x. So this becomes cos inverse cos of 7 pi by 3. Now the domain of cos is 0 to pi, and this angle 7 pi by 3, if we convert it to degrees, is 7 into 180 by 3, which gives me 420. And 7 pi by 3 does not belong to 0 to pi, that is the domain of cos. So that means we will have to evaluate it further. And okay, so 7 pi by 3 means it's 420. So this is now, let's say this is cos inverse. I can write cos 420. So cos of 7 pi by 3 is 420, and I can write it as cos of 360 plus this is 60. So that means this can be written as cos 2 pi plus 60 is pi by 3 radians, and 2 pi means no change, so I can write it as cos of 2 pi plus pi by 3, which will take this in the first quadrant where cos is positive. Now this is cos 2 pi means it's cos inverse 2 pi means no change, so cos remains cos. This is cos pi by 3, which is pi by 3, and this belongs to the domain 0 to pi. So this belongs to the domain 0 to pi, which is the domain of the cos. Our answer is pi by 3. For question number 22, we have to differentiate this with respect to x, and our equation is x squared plus y squared, the whole square is equal to x in y. So let's start differentiating this to x we get. So let's treat this as a one function, and we know that the differentiation of x raised power n, let this be x, is equal to n into x raised power n minus 1. So this is 2 into x, this is x raised power n minus 1 to minus 1 is 1 into differentiation of, again it will be the differentiation of x square plus y square, and here we are going to use a product rule. So first function into differentiation of y is dy by dx plus y into differentiation of x is 1, which gives me, so 2 into x square plus y square into, now differentiation of x square is 2x, and differentiation of y square is 2y into dy by dx, that is equal to x dy by dx plus y. Okay. So if I take 2 common here, so this is now 4x square plus y square, and here it's x plus y into dy by dx. And let's separate the variables with dy by dx. This is y. So I'm going to multiply this x with this whole term. So this is 4x into x squared plus y squared, and this whole term again with this, so plus this is 4y into dy by dx into x squared plus y squared is equal to x to dy by dx plus y. So if I club this on one side, so this is 4y plus y squared to dy by dx minus x into dy by dx is equal to y minus 4x into x squared plus y squared. Okay, this is now dy by dx into 4y into x squared plus y squared minus x equal to y minus 4x into x squared plus y squared. Okay, now we are almost done. So this is dy by dx is equal to y minus 4x into x squared plus y squared upon 4y into x squared plus y squared minus x. So this is the differentiation. Okay. For question number 23, we have to find the maximum and minimum values of the function given by, and our function is f of x is equal to y plus sine of 2x, and we know that the domain for sine 2x is, it can have -1 to 1 as the domain, and I'm going to add 5 on for each of the terms. So this becomes the function. Okay, so this becomes 4, and this is our function now, f of x is less than equal to 6. So the maximum value is 6 and the minimum value is 4. We can write the maximum value is equal to 6 and minimum value of the function is equal to 4. For question number 24, it's given that if the projection of vector I cap plus j cap plus k cap on pi cap plus j cap minus 2k cap is 1 by 3, we have to find the value or the values of p. So let the first vector be a vector, which is I cap, j cap, and k cap, and the second vector is pi cap plus j cap minus 2k cap. Now the projection of A on B will be the dot product of A and B divided by the magnitude of B. This is the projection, and which is given as 1 by 3. So 1 by 3 is equal to dot of A vector is I cap plus j cap plus k caps dot product with pi cap plus j cap minus 2k cap upon the magnitude of V, which is e square plus 1 square plus -2 square. So this is 1 by 3 is equal to, this is e plus 1 and minus 2 upon under root e square plus 5. So this is equal to p -1 upon under root p square plus 5. So if we square on both sides, the square on both sides will give me, if I square on both sides, this give me 1 by 9 p minus 1 the whole square upon p squared plus 5. So 1 by 9 is equal to p squared plus 1 minus 2p upon p squared plus 5, which is, and this is now 8p squared plus 4. If I take 2 common, so this is 4p squared minus 9p plus 2 is equal to 0. So the value of p is either 1 by 4 or 2. Okay, for question number 25th, part A, we have to find the vector equation of a line passing through the point 2, 1, 3 and perpendicular to two lines. So let's say this be a line which is passing through the point 2, 1, and 3. Now the vector equation of a line passing through a point is given by a vector equation of a line passing through a point is given by, that is, r vector is equal to a vector plus lambda into b vector, where a is the position vector of the point through which it passes, and its position vector, a vector, its position vector will be 2i cap plus j cap plus 3k cap. So I'm going to put the value of a vector, which is 2i cap plus j cap plus 3k cap plus lambda into b vector. Let this b vector be, uh, we have to find this b vector, and the b vector is the vector that is parallel to this vector, the parallel to the line. So I can write this b vector as ai cap plus bj cap plus ck cap. Now we have to find the value of a, b, and c. Okay, now where a, b, and c are the direction ratios of this line. So direction ratios of this line are a, b, and c. Now this line is perpendicular to, let's say, the first line, and this first line is this one, let's say line L1, and its direction ratios of this line, this is in the standard form, so I can directly write down the direction ratios of this line. These are the direction ratios which are 1, 2, and 3, and let these direction ratios be, A1, B1, and C1. So these two lines are perpendicular, so that means that this line is perpendicular to L1. So that means that the sum of the point of the direction ratios, and let's say our line is L. So L is perpendicular to L1. So that means sum of the product of the direction ratios A, B, C, and 1, 2, 3 should be equal to 0. So this is, I can write it down. So this is A, 2B, and 3C. So this is A plus 2B plus 3C is equal to 0, because when the lines are perpendicular, A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. So let this be our first equation. Similarly, this line is perpendicular to another line, and equation of that line is this. So its direction ratios of this line would be, uh, this line are negative 3, 2, and 5. And this is also perpendicular to L. Let this be line L2. So that means negative 3a plus 2b plus 5c. Sum of the product of the adjacent ratios should be equal to 0. So negative a, which is negative 3a, b, and 5c. Negative 3a, 2b, and 5c is also equal to 0. And let's try to solve these equations by the cross multiplication method. So I'm going to write a, b, c. This is 2, 3, 1, and 2, and 2, 5, negative 3, and 2. क्या चाहिए?
सर मैं घर से कौन से साइज की कैप्चर करके लाऊं?
अब जा रहा है तू?
हाँ जी, मैम ने बोल
छुट्टी
दिया
कर दी? मेरे चैप्टर को नहीं करने का।
घर से जो करके
हाँ,
आऊं।
तू एक लाइट और ह्यूमन आई करके आ,
अच्छा।
वो करके आ, ठीक है?
तो सिर्फ बुक से करना है, गाइड से
बुक से
करना है?
करके आओ तुमसे।
तो 4 बजे
हाँ, okay, so this is a by 10 minus 6 is equal to b by negative 9 minus 4 is equal to c by 2 plus 6. So which gives me a by 4 is equal to b by negative 14 is equal to c by 8. Let's say this is equal to k. I can take 2 common here. This is a by 2 is equal to b by negative 7 is equal to c by 4 is equal to k, which gives me a is equal to 2k, b is equal to negative 7k, and c is equal to 4k. So we have got the value of a, b, and c, and I can substitute this here. So this required equation becomes 2i cap plus j cap plus 3k cap plus lambda into the value of a. A is 2k. This is minus 2k cap. Sorry, 2k. This is minus 2k into I cap plus. Next is, sorry, first one is plus 2k. This is plus 2k and then negative 7k ij, and then it's 4k j cap plus 4k j cap. I can take k is a constant that can be taken out, and lambda into k, let's say it's another constant, so 2i cap plus j cap plus 3k cap. Let lambda into k be mu, so this is 2i cap minus 7 j cap plus 4 k cap. This is j and this is 4 k cap. Okay, so this becomes 4 k cap. So this is the required equation, 2i cap plus j cap plus 3k nu into 2i minus 7j plus 4k cap. Okay, for question number 25th, part B, the given equation of the line is this, and we have to write the direction cosines of the line. So our equation of line is 5x minus 3, and that is equal to 15y plus 7 is equal to 3 minus 10z. Okay, now let's try to get this in the standard form, which is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the standard equation of the line in the Cartesian form. So if I take 5 common here, so this is now x minus 3 by 5. And let me take 15 common, which is y plus 7 by 15 is equal to, let me take negative 10 common here. So this becomes positive. So this is z minus 3 by 10. Okay, so I can write this as x minus 3 by 5 upon 1 by 5 is equal to y. This to be in the standard form. So y negative of negative 7 by 15 by 1 by 15 is equal to z minus 3 by 10 upon negative 1 by 10. Okay, so now we have the direction ratios. These are the direction ratios. So the direction ratios of the line are 1 by 5, comma 1 by 15, comma negative 1 by 10. An LCM of 5, 15, and 10 is 30. So if I multiply all these terms with 30, so this becomes 30. So LCM of 5, 15, and 10. So LCM is 30. So let's multiply each term with 30, which gives me 6. This is 2, and this is negative 3. So these are the direction ratios. But we have to find the direction cosines. The direction ratios are A, B, and C. And the direction cosines are given by plus minus A under root A square plus B square plus C square. And second is plus minus B upon under root A square plus B square plus C square plus minus C under root A square plus B square plus C square. Now this is ABC, and A square plus B square plus C square. 6 square is 36 plus 4 plus 9, which gives me 49, and it's under root. So this is 7. So this is 7. So the direction cosines of the line are A, which is plus minus 6 by 7, comma, plus minus 2 by 7, comma. This is plus minus 3 because we have already 3 there. So I will write it as, so if you multiply that with 3, so this is uh, negative of plus minus 3 by 7, and which give me the direction cosines. The direction cosines are plus minus 6 by 7 plus minus 2 by 7. Now negative into positive is negative 3, and negative negative becomes positive. So this is negative plus 3 by 7. These are the direction cosines. So we have got the direction cosines of the line and coordinates of the point through which it passes. So these are the coordinates of the point through which it passes, and the coordinates. So let me write down the coordinates of point through which it passes are, we can get that from the equation in the standard form. This equation in the standard form, this is 3 by 5, negative 17, negative 7 by 15, and 3 by 10. So the coordinates of the point through which it passes are 3 by 5. So 3 by 5 and negative 7 by 15, comma 3 by 10. Okay, for next question, which are of 3 marks each, we have to find the integration of. So this is the integration. This integration is of the form we have quadratic equation. So this is quadratic equation at the top as the numerator. This is a quadratic equation, and this is x plus 1 the whole square upon x plus 2 into dx. And to solve this, we are going to use the partial fraction method. So let's try to simplify this first. Try to get this into some form where we can easily different integrate this. So this is x squared plus x plus 1 upon x plus 1 the whole square into x plus 2. So this can be written as a upon, this is x plus 1 plus b upon x plus 1 the whole square plus 1 upon, sorry, c. This is c upon the x plus 2. Now this can be, if this can be done in this form where we have the values of a, b, and c, it would be easier for us to integrate. So this is now x square plus x plus 1 upon x plus 1 the whole square into x plus 2. And this is now LCM is x plus 1 the whole square into x plus 2. Okay, so this is a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 the whole square. So this gets cancelled. And finally, we are left with x squared plus x plus 1. So this is x squared plus x plus 1 is equal to a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 the whole square. Okay, if I put x is equal to -1, so -1 square is 1, and so here it's -1 square plus -1 plus 1. This reduces to 0. This also reduces to 0, and we are left with b -1 plus 2, which gives me 1 is equal to b. So b is equal to 1. So the value of b is 1. And now if I put, similarly, if I put here x is equal to -2. So if I put x is equal to -2 square, this is -2 plus 1 is equal to, this term becomes 0, negative, this term becomes 0, and we are left with c. So this is -2 plus 1 the whole square, which is -1 the whole square, which is 1. So this is c. This is 4 minus 1, and c is equal to 3. So we have got c is equal to 3. Now we have to get a. So let me put x is equal to 0. So if I put x is equal to 0, so this becomes 1. This equation reduces to 1. This is now 1. This is 2a plus this is 2b plus this is, if I put x is equal to 0, this is c. Now let's put in the value of b, which is 1. So this is 2c, which is 3, which gives me 2a is equal to 2 plus 3 is 5 minus 1 is -4, and a is now equal to -2. So I have got the value of a as -2. So if I put these values here, so this becomes a is -2 by x plus 1 plus b is 1 and c is 3. B is 1 upon x plus 1 the whole square, and c is 3 upon x plus 2. So now this integration becomes integration of, this is -2 upon x plus 1 into dx plus, this is integration of 1 upon x plus 1 the whole square plus integration of 3 upon x plus 2 into dx. Okay. Now for this, -2 is out, and integration of x plus 1 is log of x plus 1. This, if I take x plus 1 as t, so this is differentiating with respect to x gives me dx is equal to dt. So here it's dx. So this becomes 1 by t square, which is equal to t raised power -2, and integration of this is t raised power -2 plus 1 upon -2 plus 1, which is 1 by negative t, 1 by -1 by t. So this becomes, and t is x plus 1, so 1 plus. So this is now negative of, this integration is negative of 1 upon x plus 1 plus 3 is out, and this is log of x plus 2, and let's add the constant c. So our integration is -2 log of x plus 1 minus 1 upon x plus 1 plus 3 log of x plus 2 plus c. Okay, for question number 27, part A, we have to evaluate this definite integral. And let's say this is our integral I. So we are going to make the substitution for this 2x. So let 2x is equal to t, and we will find the new limit. So differentiating this with respect to t, we get. So differentiation of 2 is out, x is dx by dt is equal to 1, which gives me dx is equal to dt by 2. So I can replace this with dx by dt, and let's find out the new limits as well. So when x is equal to pi by 4 t, t is equal to 2 into pi by 4, which is equal to pi by 2. And when x is equal to pi by 2, t is equal to 2 into pi by 2 is equal to pi. Okay, now I is equal to integration of, so instead of x pi by 4, when x is pi by 4, t is pi by 2, so pi by 4 becomes, this is pi by 2 and this is pi, and now this becomes e raised power t. Let's make the substitution. This is now 1 minus sine t and 1 minus cos t, and dx is dt by 2, so half is out, and instead of dx, now differential element is dt. Okay, now we know that sine, if sine 2t is 2 sine t into cos t and half of this angle, so sine t becomes 2 sine t by 2 into cos t by 2. Similarly, this cos 2x, so cos 2x is 2 cos square x minus 1, and if we take this t, so this is t cos 2t, so this is 2 cos square t minus 1, and if we take the half of this, so cos t is equal to 2 cos square t by 2 minus 1, which gives me 1 plus cos t is equal to 2 cos square t by 2. So let's make this substitution in this. So our integral now becomes, this is equal to half integration of y by 2 pi, this is e raised power t, and insert here I can write 1 minus 2 sine t into cos t, sorry, sine 2 t by 2 cos t by 2, and 1 minus cos t, this becomes, okay, this was 1 minus cos t, so you will have to take, let's take 1 minus 2, the other form 1 minus 2 sine square t. So this becomes cos t is equal to 1 minus 2 sine square t by 2. And now I can write that 1 minus cos t is equal to 2 sine square t by 2. So this is 2 sine square t by 2. So this is now 2 sine square t by 2 into dt. Okay. So simplifying this further, this is pi. Okay, so this is e raised power t, and I can write it as, this is half cosecant square t by 2 minus, this becomes 2 and 2 gets cancelled, and we are left with cot t by 2 into dt. Okay, now let me put it here. So this is cos t by 2 plus half cosecant square t by 2 into dt. Now this is our function and this is its differentiation. And we know that integration of e raised power x into f of x plus f dash x is equal to e raised power x plus c. So this becomes, so this is now half uh, e raised power t, and f of x is negative cos t by 2, and evaluate it for the limits pi to pi by 2. Okay, so let's evaluate it for the limits uh, pi to pi by 2, and this should be actually, so this is our f of x. When it's f of x, let me take negative out. So if I take negative out, this becomes positive and this becomes negative. So this is now f of x, and this its differentiation is this, because we know that the differentiation of cot t by 2, differentiation of cot is negative cosecant squared t by 2, and it has to be divided by the differentiation of t by 2, which is half. So this is now half. So cot t by 2. Okay. So it is of the form e raised power x into f of x plus f dash x, which is e raised power x into f of x plus c. So this becomes, this negative is out. So this becomes e raised power x into f of x. And now let's evaluate this. So this is negative half. Let me put e raised power pi. This is into cot pi by 2 minus e raised power pi by 2 into cot. This becomes pi by 4. Okay, so negative half into e raised power pi. Now cot pi by 2 is 0. This is negative e raised power pi by 2, cot pi by 4 is 1. And this is now negative half into negative e raised power pi by 2, which becomes half into e raised power pi by 2. So our answer is half into e raised power pi by 2. This is our integration. Okay, for question number 27, part, we have to evaluate the integral, and let's say this is our integral I. Let this be equation 1. And we are going to use the property a to b of the definite integral, which says a to b f of x into dx is equal to a to b. I can write it as a plus b minus x into dx. Okay, so if I apply this on this given integral, this is now minus 2 to 2 f of, sorry, this instead of x, we can write a plus b, and this is a and this is b. So this is now negative 2 plus 2 negative x on 1 plus 5 into negative 2 plus 2 negative x into dx. So this becomes I is equal to integration of negative 2 to 2, and this is now square. So this becomes negative x square. This gets cancelled. This is 1 plus 5 raised power negative x into dx. Sorry, which is equal to negative 2 to 2. This is x squared upon 1 plus 1 upon 5 raised power x into dx. So I is finally this is, so x square, let's take LCM 5 raised power x. So this is 5 raised power x plus 1 into dx, which is equal to, this is x square into 5 raised power x upon 1 plus 5 raised power x. Okay, let this be equation 2. So I'm going to add 1 and 2. So adding 1 and 2 gives me 2i is equal to x squared plus x squared into 5 raised power x upon 1 plus 5 raised power x into dx. Sorry, so 2y is equal to, this is negative 2 to 2. Okay, take x square common. This is 1 plus 5 raised power x upon 1 plus 5 raised power x into dx. This gets cancelled. So differentiation of integration of x square is x cubed by 3. And the limits are negative 2 to 2. So 2I is equal to 1 by 3 and 2 cube is 8 minus 2 cube is minus 8. So I is equal to 1 by 6 and 8 plus 8 is 16. So this is into 16, which gives me 8 3. So I integration is, the value is 8 by 3. Okay, for question number 28, part A, we have to find the integration. Let's say this be integral I, and let's make the substitution here. So e raised power x, e raised power x. So we are going to replace e raised power x with t and differentiate this with respect to t. And so this is differentiating with respect to t. So e raised power x differentiation is e raised power x, and x with respect to t is dx by dt. T is 1, which gives me e raised power x into dx is equal to dt. So making the substitution, I is equal to integration, this becomes dt, and this is now under root 5 minus 4 e raised power x is t, minus this becomes e raised power x is t, so e raised power 2x is t square. Now 5 minus 4t minus t square, let's complete the square for this. This is t square, which is equal to negative of t square plus 4t minus 5. So multiply the coefficient of t with half, which is 2. So add and subtract the square of 2. Okay, which gives me negative. So this term, and this term makes t plus 2 the whole square. Minus 5 minus 4 is minus 9. So this is negative 3 square. And so now this is a square minus b square. Okay, so instead of this, now I can write this is dt, and instead of this, I can write this is under root 3 square minus t plus 2 the whole square. Okay, and 3 square minus t plus 2 the whole square, which is, this is of the form, we know that integration of 1 upon under root of a square minus x square is equal to sine inverse x by a plus c. So this becomes, this is now sine inverse x. Instead of x, we have t plus 2, which is in the linear form. So t plus 2 by a is 3. So sine inverse t plus 2 by 3 plus c. And now let's make the final substitution for t. T was substituted for e raised power x plus 2 by 3 plus c. This is our integration. Okay, for next question, that is question number 28, part B. This is question number 28, part B. We have to evaluate this definite integral, and I can write this as, so this is 0 to pi by 2 definite integral, and this is root of sine x, and cos raised power 5x, I can write it as cos square x, the whole square, and 1 cos x is left, so this is cos x into dx. Okay, now we are ready to make the substitution. So let sine of x is equal to 2 and differentiating this with respect to t. So we are differentiating this with respect to t, not with respect to x. So this is cos x into dx is equal to dt. But now let's make the substitution here. So cos x into dx is dt. So this is equal to 0 to pi by 2. This is under root t, which is t raised power half cos square x. So cos square x, I can write it as 1 minus sine square x. So 1 minus sine square x and cos x into dx is dt. Okay, so 1 minus sine square x is, so this is 0 to pi by 2. And let me get the new limits as well. So once we are, uh, so when x is equal to 0, t is equal to sine 0, 0. And when x is equal to pi by 2, so sine 90 is 1. So the new limits are 0 to 1. So let me put in the new limits as well, 0 to 1. So this is now our integral, and 1, instead of cos square, it's 1 minus sine square x, the whole square, dx, cos x into dx is dt. So this becomes I is equal to 0 to 1. This is t raised power half 1 minus t square, the whole square into dt, which becomes I is equal to integration 0 to 1. This is t raised power half, and this is a minus b the whole square. So this is a square plus b square minus 2 into a into b into dt. Okay, finally, if we open that, this is 0 to 1. This is t raised power half plus t raised power half plus 4. So half plus 4 is 9 by 2 minus 2 into t raised power half plus 2 is 5 by 2 into dt. Okay, so let's integrate this now. So integration of t raised power half is t raised power half plus 1, which is 3 by 2 on 3 by 2. Evaluate it for the limits 0 to 1, plus this is t raised power 9 by 2 plus 1, which is 11 by 2 on 11 by 2. Integrate 0 to 1 minus 2, and this is t raised power 5 by 2 plus 1. 5 by 2 plus 1 is 7 by 2 upon 7 by 2. Okay, so this can be written as 2 by 3 and t raised power 3 by 2, 1 to 0. This becomes, this is now 2 by 11, and t raised power 11 by 2, 0 to 1 minus 2 into, this is 2 into 2 by 7, t raised power 7 by 2, 0 to 1. Okay, so finally this is 2 by 3, because if you put 1 raised power, anything is 1, so plus 2 by 11 minus 4 by 7. So 2 by 3 plus 2 by 11 minus 4 by 7, and we have the LCM. So if we LCM as 231, which gives me 3 sevens are is 21, 3 sevens are, this is 154 plus 11 2 and 1, so this is 42 minus 154 minus 42 minus, this is 7 3s are is 21, 33, 33 into 4 is 132. So 33 into 4 is 4 to the 12, 132, and which gives me 154 plus 42 is 4 plus 196 minus 132 by 231, which is 4 6. So 64 by 231 is the answer for this one. Okay, for question number 29's part A, we have to find the particular solution. So this differential equation can be written as, I can write it as dy upon dx is equal to x upon x plus y upon x. So this becomes dy upon dx is equal to 1 plus y upon x. Now, let's make the substitution. Let's say y upon x. So y upon x is equal to v, which gives me y is equal to vx, and its differentiation is dy by dx is equal to v plus x into dv by dx. So this is equation 2, this is equation 1, and comparing this, we get v plus x into dv by dx is equal to 1 plus vy by x is v. So v and v gets cancelled. And finally, we have x into dv by dx is equal to 1, which gives me, I can write it as dv is equal to integration of dx upon x. Not the integration now. So if we use the integration, if we integrate on both sides, this becomes v is equal to, this is log x plus c. Now v is y by x, so y by x is equal to log x plus c, and it's given. I can write it as, so y by x, if we get the value of c, so it's given in the question that we have to find when x is equal to 1, y is equal to 0. So when x is equal to 1, y is equal to 0. So this becomes 0 by 1 is equal to log 1 plus c. So 0 by 1 is 0. So c is equal to log 1 is also 0. So c is equal to 0. So c is equal to 0 means that this equation now reduces to, so this becomes y by x is equal to log x, and y is equal to x log x is the particular solution for this one. Here for question number 29's part B, we have to find the general solution of the differential equation, and the differential equation is e raised power x into tan y. So let me see if we can separate the variables. So e raised power x into tan y into dx plus this is, let me shift this to the other side. So I'm left with 1 minus e raised power x into secant square y into dy is equal to negative e raised power x into tan y into dx. Okay, this further can be written as secant square y into dy upon tan y is equal to negative e raised power x upon 1 minus e raised power x into dx. Now let's integrate this on both sides. So if we integrate on this one both sides, this secant square y upon tan y into dy is equal to integration of negative, this is e raised power x. Let me write the negative sign. So this is integration of negative e raised power x upon 1 minus e raised power x into dx. Now, these two are of the form, this is f of x, and this is its differentiation f dash x. So its differentiation, this is the function, and its differentiation is this. And we know that integration of f dash x on f of x is equal to log of f of x. So this is the formula for integration of differentiation upon the function is equal to log of f of x. So we can use this in both, on both these sides. So this becomes log of tan y is equal to, this becomes log of 1 minus e raised power x plus log c. So this is now log of tan y is equal to, this is log a plus log b, so log a into b. This gets cancelled. And finally, our equation is then y is equal to c into 1 minus e raised power x. Okay, for question number 30, we have to solve the linear programming problem graphically, and we have to find the objective function minimize z. This is the objective function subject to the constraints. These are the constraints. So let's first of all, let's get our points. So x for x plus y to y is equal to 8. The points are when x is equal to 0, y is equal to 4, and when y is equal to 0, x is equal to 8. And similarly for 3x plus 2y is equal to 12. Our coordinates would be when x is 0, y is 6, and when y is 0, x is 12. So these are the coordinates for this. Okay, let's plot the graph, and let me get the horizontal and vertical grids. Okay, let's plot the graph, and I'm going to take the scale of 2. So this is 0, 0. Let's say this is 2, this is 4, this is 6, and this is 8. Similarly here it's 2. Let's say this is 2, this is 4, 6, and 8. Okay. Okay, for the first one, our points are 0, 4. So this is 0, 4, and second one is 8, 0. So this is 8, 0, and let's join them. Okay, and this is now x plus 2y is equal to 8. Next is 0 to 6. 0 comma 6 is here on the y-axis, and 4 comma 0 is here. Okay, if we join them, okay, now let's find out the solution region for them. So x plus 2y is less than equal to 8, and I'm going to check this equation for 0, 0, that is origin. So 0 is less than equal to 8, which is true. So its solution region is towards the origin. Next one is 3x plus 2y is less than equal to 8. And if I check this for the origin, 0 is less than equal to 12, which is true. So it's also towards the origin. So this is the common region. And our common region is this one. And it has the corner points. So let me write down the corner points for this region. So now I'm going to write down the corner points and minimum z value for that is minus 3x plus 4y. Our first corner point is a, which is 0, 0. So its value is 0. And second is, let's say b, which is 0 comma 4. Second is b, 0 to 4, and this is 0 because 4 4s are 16. And the next is c. Let's say this be c, so this is 2 comma, the point of intersection of these would be 2 comma 3. So our third point is 2 comma 3, and so let this be c 2 comma 3, and the value for this is minus 3 into 2 is negative 6 plus 3 into 4 is 12, which is equal to 6. And the next one is d, 2 comma, after 2 comma 3 it's 4 comma 0, so this is 4 comma 0. So minus 4 4 minus 3 into 4 is negative 12 plus 0, which is equal to negative 12. So these are the values at the corner points, which are 0, 16, negative 12, and 6. And out of this is the minimum value. So we have to find the minimum value. The minimum value is negative 12, and that is at 4 comma 0. Okay, for question number 31, it's given that from a lot of 30 bulbs, which includes 6 defective bulbs. So total bulbs here are 30, and defective ones are 6. So probability of defective is 6 by 30 is equal to 1 by 5. And the probability of getting non-defective when one bulb is selected at random is 1 minus 1 by 5, which is 4 by 5. So we have the probability of defective and the non-defective bulbs. Now, it's given that two bulbs are drawn at random and one by one with replacement. We have to find the probability distribution of the number of defective bulbs and hence find the mean. So let's say x is the random variable for the number of defective bulbs. Now either none of them is defective or one of them is defective, or both of them are defective. So let's find the probability of x is equal to 0. So that means that the first one is also not defective and the second one is also not defective. So 4 by 5 into 4 by 5, which gives me 16 by 25. Now probability when one of them is defective. So that means either the first one is defective. So we have the defective bulb, and the second one is non-defective, or the probability that first one is non-defective and second is defective. Okay, so let's find out the probability of one. So probability of defective bulb. So probability of defective bulb is, so defective bulb is 1 by 5 and non-defective is 4 by 5 plus non-defective is 4 by 5 into 1 by 5, which gives me 4 by 25 plus 4 by 25, which is equal to 8 by 25. So the probability that one bulb is defective is 8 by 25. Now let's find out the probability that both of them are defective. So probability that both of them are defective, that is the first one is defective and the second one is also defective, which is 1 by 25. Now let's write it in the distribution table. So 0, 1 and 2 are the values and the probability of x. So probability of x here is, for 0 is 16 by 25, 8 by 25 and 1 by 25. So this is the probability distribution table. Now we have to find the mean as well. So mean of the probability distribution is 0 into 16 by 25 plus 1 into 8 by 25 plus 2 into 1 by 25. So this is obviously 0. This is 8 by 25 plus 2 by 25, which is equal to 10 by 25. And finally, it's 2 by 5. That is the mean. Okay, for next question, which is question number 32, we have to find the inverse of the square matrix A. And this is the square matrix. So this is question number 32. The square matrix is given as A is equal to 1, negative 1, 2, 0 to negative 3, 3, negative 2, and 4. So first of all, let's check whether A inverse exists or not. For that, we have to find our determinant of A. And let's evaluate it along row R2. So this is plus negative plus negative. So 2 into determine, remove the row and the column for 2. I'm left with 1, 2, 3, 4, and then negative of negative 3. The determinant left is 1, negative 1, and 3, and negative 2. So which gives me the determinant as A is equal to 2, 4 minus 6 plus 3, negative 2 plus 3. So determinant A is equal to 2 into negative 2 plus 3 into 1, which gives me negative 4 plus 3, which is equal to negative 1, which is not equal to 0. So that means A inverse in this. So A inverse exists because we have determinant of A as negative 1. Now let's find the joint of A. So to find the joint of A, let's find the cofactor matrices A11, A12, A13, and so 1 plus 1 is 2, which is even, so positive, negative, and positive. Remove the row and the column for first element, and it's 2, negative 3. So 2, negative 3, negative 2, and 4, and A1. So I have to find out A12. So remove the row and the column for the second element in the first row. So 0, negative 3, 3, and 4. So this is 0, negative 3, 3, and 4. Similarly, remove the row and the column for this one, 0, 2, 3, negative 2. So 0, 2, 3, and negative 2, which gives me this is equal to 2, 4 are 8 minus of 6, which is equal to 2. This is negative of negative 9, which is equal to 9, and this should be equal to negative 6. So I have got the first column for the adjoint, which is 2, negative 9, and this is minus 9, which is 9, minus 9. So joint of A, so adjoint of A has the first column, this is 2, negative 9, and negative 6. Similarly, we can get the cofactors for the second row. So these are 2, 1, 2, 2, and 3. 2 plus 1 is 3, odd negative. This is positive and this is negative. Okay, remove the row and the column for 2, 1. So if I remove the row and the column, negative 1, 2, negative 1, 2, negative 2, and 4. And if I remove the row and the column for this, this is 1, 2, 3, 4. 1, 2, 3, and 4. And for 2, 3, remove the row and the column for this one, 1, negative 1, 3, negative 2. So 1, negative 1, 3, and negative 2. So this is equal to negative, negative 4, negative of negative 4, which is equal to 0. This is 4 minus 6, negative 2, and this is negative of negative 2 plus 3, which is equal to negative 1. So 0, negative 2, and negative 1. Similarly, we can find the cofactors for the third matrix, third row, sorry, this is 3, 1, 3, 2, and 3, 3. Now assign the sign 3 plus 1 is 4, so even, positive sign, or negative sign, positive. Okay, remove the row and the column, third one, the 3, 1. Remove this, and we are left with negative 1, 2. So this is negative 1, 2, 2, and negative 3. 3, 2. So remove the row and the column for this. So 1, 2, 0, and negative 3. So 1, 2, 0, and negative 3, 3, 3. So find out, remove this one. So 1, negative 1, 0, 2. 1, negative 1, and 0, 2. Okay, this is now 3 minus 4. This is equal to negative -3, which is equal to 3, which is equal to, this is equal to 2. So 3 minus 4 is -1, 3, and 2. So -1, 3, and 2, this is the adjoint. And we have to find the A inverse. So A inverse is adjoint A divided by negative. So this is 1 by -1, which gives me A inverse as -2, 0, 1, 9, 2, -3, 6, 1, and -2. So we have got the A inverse -2, 0, 1, 9, 2, -3, 6, 1, -2. Now let's use this A inverse to solve this system of equations. Okay. Now this system of equations can be written in the form Ax is equal to B and x is equal to A inverse into B. So X is a matrix which has the elements X, Y, and Z. And A inverse, we have the A inverse which is -2, 0, 1. This is 9, 2, -3, and 6, 1, and -2. Okay, and B is the matrix of the constants, and the constants are 1, 1, and 3. So we have written these matrices in the matrix form where x is equal to A inverse B. So let's multiply them. So x, y, z is now equal to, so let's multiply them. And okay, so multiply the first row with the only column that we have. So -2 plus 0 plus 3. And this is 9 plus 2, -9. This is 6 plus 1, -6. This gets cancelled. And finally, we have it's 1, it's 2, and it's 1. So value of x is 1, y is 2, and z is 1. 1, 2, and 1. Okay, for a question number, next question. This question number 33, we have to use integration to find the area of the region bounded by the parabola y square is equal to 4ax. So parabola y square is equal to 4ax has its vertex on the origin and it opens on the positive direction of x-axis. So this is the parabola having the equation y square is equal to 4ax. Okay, now we have to find the area of the region bounded by the parabola and its latest rectum. So latest rectum, so let's say the vertex of this parabola of equation y square is equal to 4ax is a comma 0, and latest rectum is a line that passes through the vertex. So this is a line that passes through the vertex. That means that this line has the latest rectum has the equation x is equal to a. So this is the region that we are supposed to find out the area for this region. So the required area is equal to, because this region is symmetrical about the x-axis, so I can take the limit 0 to a and 2 times. I'm going to find out the area of this region and multiply it with 2, and it's y into dx. So from where do you get the value of y? So you get the value of y from here. So y is equal to under root 4ax, which gives me y is equal to 2 under root a into x. So y is equal to 2 under root a into under root x. So I can write here 2 times 0 to a and 2 under root a. So this is 2 under root a into root x into dx. Okay, so 2 under root a is constant, so this becomes 4 under root a 0 to a x root x is x raised power half into dx, which becomes 4 under root a x raised power half. So integration is x raised power 3 by 2 by 3 by 2 for the limits 0 to a. So this is 4 root a into 2 by 3 x raised power 3 by 2 0 to a. So this is now 8 under root a by root 3 into a raised power 3 by 2 minus 0, which gives us 8 into under root a 3 into now a 3 by 2 can be written as a cubes half. So a cubes half means this can be written as a under root. So which gives us this is a by 3 and under root a into under root a, which is now 8 a square by 3 square units is the area, required area. Or, sorry, question number 34, part A. If n denotes the natural numbers and a relation set of natural numbers and R is the relation that is defined from on n cross n, and relation says that the ordered pairs AB is in relation with ordered pair CD if A into D uh, into B plus C is equal to B into C into A plus D. So this relation is defined for the natural numbers to natural numbers. So this is the natural number. This is the codomain. So n to n the relation is defined, and we have the ordered pairs here A, B, and C, D. Now they are in relation if A into D, that is A into D, and whatever is left, add them, the other elements is equal to B into C into A plus D. So then we can say that A, B is in relation with C, comma D. Now let's check it for the equivalence relation. For that, let's check the reflexive, whether it's reflexive or not. So for reflexive, we have to check whether A, comma A is in relation with itself or not. So I'm going to check the relation of A, comma with A, comma B. So for that, I have to multiply A with B and add A plus B, the and then B into A, which is AB, and then A plus B. So AB, obviously these two sides are equal. That means A comma B is in relation with A comma B. That means this relation R is reflexive. So R is reflexive. Now let's check it for symmetric. And to check it for symmetric, let's say A comma B is in relation with C comma D. So this implies that AD into B plus C should be equal to BC into A plus B. Now, if this is equal, I can change the order or change the sides. BC into A plus D is equal to AD into B plus C. So that means C comma D is in relation with A comma B. So that means R is symmetric. Okay, now let's check it for transitive. And to check it for transitive, let's consider uh, two ordered pairs or the set of two ordered pairs to be in the relation. Now let's say A comma B is in relation with C comma D. Let's say A comma B is in relation with C comma D, and this is D. So C comma D is further in relation with let's say E comma F. So if we are able to prove that A comma B and E and F are also in relation, then this is transitive. So this is in relation means that A into D plus B into C is equal to BC into A plus D. And next one is C into F in plus E into D. C into F plus E into D is equal to D into E into C plus F. This is what we get from these two relations. So A into D plus B plus C is equal to B into C into A plus D. Okay, from this one, if I use this, I can write it as B plus C upon BC is equal to A plus D upon AD. And which gives me, if I separate them, so B upon B plus C, C upon BC is equal to A upon AD plus D upon AD. This gets cancelled. And finally, I have 1 upon C plus 1 upon B is equal to 1 upon D plus 1 upon A. Okay. Okay, next one is if I use this one, I can write it as E plus D upon DE is equal to C plus F upon CF. So this becomes 1 by D plus, this is 1 by D plus 1 by E is equal to 1 by F plus 1 by C. So I have these two, 1 by C plus 1 by B is equal to this. Okay, now I am going to add these two results. So let this be equation 1, this be equation 2. So I'm going to add these two. So adding these two will give me uh, so 1 by C plus 1 by B plus 1 by D plus 1 by E is equal to 1 by D plus 1 by A plus 1 by F plus 1 by C. Okay. Now, for these two, can cancel these two. This gets cancelled and this gets cancelled. So finally, I have 1 upon B plus 1 upon E is equal to 1 upon A plus 1 upon F. And if I take LCM for these, so this is LCM BE, so this is E plus B is equal to LCM AF, F plus A. And I can write it as, so this becomes, let's cross multiply this, so A into F into B plus E is equal to BE into A plus F. Okay, if this is the result, then according to this, A into B is in relation with E into F. So that means R is transitive. So R is transitive. Now R is transitive, R is symmetric, and R is reflexive. So that means R is equivalence relation. Okay, for question number, this is question number 34, part B. And this function is defined from all real numbers. So domain here, is all real numbers except minus 4 by 3, and the codomain is all real numbers. Now, so it has all real numbers, except minus 4 by 3, and function is 4x upon 3x plus 4. So we have to check whether it's 1 1 or not. So for that we will take two real numbers here, and let's say these two are their two images, and we will make them equal. So these two become equal as well. So that means f is 1 1. So let's say x1 and x2, they belongs to the real numbers, all real numbers except minus 4 by 3. So, and if f of x1 is equal to f of x2, so let's see what result we will get. So this is 4x1 upon 3x1 plus 4 is equal to 4x2 upon 3x2 plus 4. Okay, let's cross multiply this 4 and 4 gets cancelled. So this is x1 into 3x2 plus 4 is equal to x2 into 3x1 plus 4, which gives me 3x1 into x2 plus 4x1 is equal to 3x1 into x2 plus 4x2. Take this on, all these on the left. So this gets cancelled. 4x1 is equal to 4x2, and which gives us x1 is equal to x2. So that means the function is 1, 1, because if the images are equal, the elements in the code in the domain are no different. For every x, there is a value of y, a unique image. So now let's check whether it's onto function or not. So for onto function, our function is f of x is equal to 4x upon 3x plus 4. Okay, f of x is y. Okay, finally we have x, which is 4y upon 4 minus 3y. Now this x is defined for all values of y. Now there here y cannot be, so here y cannot be 4 by 3, because if y is 4 by 3, then this x is not defined. So for y is equal to 4 by 3, x is equal to 4y upon 4 minus 3 into 4 by 3. This gets cancelled. This is 4y by 0, which is not defined. So that means that here all the all real numbers except 4 by 3. So 4 by 3. So 4 by 3 will not have any x here. Okay, so that means that codomain, so the range of the function, so that means now x is real. So this x is real only when y is not equal to 4 by 3. So x is real only when y is not equal to 4 by 3. So that means the range of the function is all real numbers except 4 by 3, and this is not equal to codomain, which is R. So not equal to codomain of F. So that means that the F is not on. So I can write that F is okay. For question number 35th, part A, we have to show that the following lines do not intersect each other. So the lines, if the lines do not intersect each other, that means there is some distance between them. If they do not intersect each other, so that means they are parallel and there is a distance between them. And if somehow they intersect each other, so that means the shortest distance between them should be equal to 0, because they are intersecting at the point. And to find the shortest distance of two lines in the Cartesian form, it's the formula is x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, that are the ratios of the first line, a2, b2, c2, the Dyson ratio of the second line, the shortest distance, and take the determinant of that into, this is VC and BC, CA and CA, and then AB and AB. So let's write 1, 2, 2, 1, 1, 2, 2, 1. 1, 2, and 2, 1, and square of these, okay, and under root. Okay, this is the shortest distance and this should not be equal to 0. So if this is equal to 0, that means the lines intersect. And if this is not equal to 0, that means the lines do not intersect each other. So x2 and x1 are the, so here x2 is the point through which this line passes, which is negative 2. If I write this in the standard form, let me write this in the standard form. The first one is x minus 1 by 3. Second one would be x minus of minus 1 by 2 and z minus 1 by 5. So here this line passes through the point. This is 1, negative 1 and 1. 1, negative 1 and 1. These are our x1, y1 and z1. So this is uh, x1, y1 and z1. Okay, for the second equation is x minus of minus 2 by 4 is equal to y minus 1 by 3 is equal to z minus of minus 1 by negative 2. And here the values point through which it pass is negative 2, 1 and negative 1. So this is x2, y2 and z2. Okay, let's put in the values of x2 minus x1. So x2 minus x1, negative 2, negative 1 is negative 3. This is 1 minus of minus 1 is 2. X2 minus y2 minus z2 minus z1 is negative 2. So negative 3, 2 and negative 2. Now A1, B1 and C1 are, these are the A1, B1 and C1, 3, 2 and 5. So 3, 2 and 5. And these are A2, B2 and C2, 4, 3, negative 2. So 4, 3 and negative 2. We have to find the determinant of this. And this has to be divided by B1. So A1, B1, this is B1 is 2 into C2. A1, B1, C1, this is C2, negative 2 minus B2 is 3 into C1 is 5, the whole square plus. Okay, so 2 into negative 2, negative 5 into 3, and then it's 3 into negative 2. Replace, put in the values minus 4 into 5, the whole square, and then plus 3 into 3. I'm just putting in the values, the whole square. Okay, let's find out the determinant of this one. So this one is, let's evaluate it around first, along first rows, the positive, negative, and positive. So minus 3, and the determinant we are left with is 2, 5, 3, and a negative 2, then negative 2, and determinant we are left with is 3, 5, 4, negative 2, then negative 2, and then 3, 2, 4, and 3. Okay, divided by, this is 2 into, this is negative 4, negative 15, the whole square plus negative 6, negative 20, the whole square plus 9 minus 8, the whole square. Okay, so which finally comes out to be, okay, this is now negative 3 into negative 4 minus negative 15, negative 2, negative 6 minus 20, negative 2, 9 minus 8, and this is under root, sorry, this is under root, this is also under root, and this is negative 19 the whole square plus negative 20 the whole square plus 9 minus 8 1 the whole square, which gives me negative 3 into negative 19 minus 2, negative 26 minus 2 and 1 upon. Now 19 square is 361 plus 26 square is 676 plus 3 into negative 6, negative 6 and negative 20. Okay, and 1 square is 1. Okay, now 19 into 3 is 57 plus 52 minus 2. This is under root, and if I add them 6, 7 and 8, and then it's 7, 6, 13, and then 13, 69, and 110. So 1038. So 57 plus 52. So this is 50, which is 117 upon 1038, which is not equal to 0. So this is the distance. So that means the lines will, so there is some distance between the lines, which is the shortest distance. So lines will never intersect each other. So for question number 35th part B, we have to find the angle between the lines. This is equation of the line. So this equation of the line, let's write this in the standard Cartesian form. So I can write it as x upon 1 by 2, that this is equal to y upon 1 by 3 is equal to z upon negative 1. And so this is the standard equation of the line in Cartesian form. And so I can, this is x minus 0, y minus 0, and z minus 0. Okay, this is our first equation. And which, or I can write it as uh, so x minus 0, y minus 0, and z minus 0 by negative 1. So it's a half 1 by 3 and negative 1. So LCM of 2 and 3 is 6. So let's multiply all these with 6, which gives me x minus 0, and multiply this with 6 gives me 3. So 1 minus 0, so multiply all of them with 6. Because the LCM of 2 and 3 is 6, so this becomes 3, this becomes 2, and this becomes z minus 0 by negative 6. Okay, so 3, 2, and negative 6. Similarly, for this equation, I can write it as this is x minus 0 by 1 by 6 in the standard form is equal to y minus 0 by negative 1 is equal to this is z minus 0 by negative 1 by 4. And LCM of 6 and 4 is 12, so multiply all of them with 12, so which gives me 2 is equal to y minus 1, multiply them with 12. So multiply them with 12 gives it's negative 12, it's z minus 1, and 12 it's negative 3. So this is the equation 2, negative 12, and 3. And now we know that the theta cos theta angle between two lines is given by cos theta, where a1 into a2 b1 b2 plus c1 c2, and it's a1 square plus b1 square plus c1 squares under root of a2 square plus b2 square plus c2 square. So where are these a1 a2 a1 b1 and c1? This is a1 b1 c1, this is a2 b2 c2. These are the direction ratios of the lines. That's why we converted them to the standard equation. So let's put in the values. So if I put in the values, a1 is 3, so this is 3 into 2 plus 2 into negative 12 plus negative 6 into negative 3 upon under root a square. This is 3 square plus 2 square plus negative 6 square into under root. This is 2 square plus negative 12 square plus negative 3 square. Okay, let's try to simplify this. This is cos theta is equal to 3 theta is 6, negative 24 plus 18, and this c square is 9 plus 4 plus 36 into 4 plus 144 plus 9. Okay, this cos theta is now equal to 24 minus 6 minus 24 is negative 18. So we don't have to calculate this, because this is going to be 0. 9 plus 4 is 13. 13 plus 13 plus 36 is 49 into this is 9, 4 is 13, and 9 plus 4 is 13, so this is 157. Obviously this is going to be 0. So the angle between them, cos theta is equal to 0, so that doesn't mean the angle is 0, that means the cos theta is 0. And we know that cos is 0 for angle pi by 2, so that means theta is equal to pi by 2. So these two lines are perpendicular to each other. Therefore, question number 36, that is case study question, and we know that for a real value function, left hand derivative is given by this formula. For the right hand derivative, it's this formula. Now the function is said to be differentiable. X is equal to a if left hand limit and right hand limit exists and both are equal, and our function is given. So what is the right hand limit of f of x is equal to 1? So let's jump to the solution first. So right hand limit, we have right hand derivative we have to find out, and right hand derivative is given by given that its limit h tends to 0. So it's given in the formula h tends to 0, f of a minus h minus f of a upon this is uh, for the right hand derivative. It's the right hand derivative. We are going to find out the right hand derivative is this one. So we have f of a plus h. This is a plus h minus f of a upon h. Okay, and we have to find the derivative at x is equal to 1. So our a is 1. Okay, let's put in the value. So this becomes limit. This is limit h tends to 0, and f of a plus h. Let's put in the value. A is 1. So 1 plus h minus f of 1 upon h. Now, what is f of 1 plus? Because this is a right-hand derivative, so we have to take the value greater than 1. So our function is x minus modulus of x minus 3. So that gives us for 1 plus h, it's modulus of 1 plus h minus 3. So this becomes limit h tends to 0. Now f of 1 plus h. F of 1 plus h is modulus of 1 plus h minus 3 minus 1. F of 1 is 1 minus 3 from this. So if we use this, so f of 1 is equal to modulus of 1 minus 3. And let's find this out upon h. So this is now limit h tends to 0. So this is h minus 2 minus modulus of minus 2 upon h. And this is now limit. Okay. Now this has to be positive. So that means, so for this to be positive, for modulus x to be positive, this is negative x. So I can write this as this value has to be negative of h minus 2, and this is minus modulus of minus 2 is 2, so this is minus 2 upon h, which becomes limit h tends to 0. This is negative h plus 2 minus 2 by h. So this is now limit h tends to 0, negative h by h, which is negative 1. So our right hand derivative is negative 1. Okay, now let's find out the left hand derivative. Okay, the formula for the left hand derivative is also given. This is the formula for the left hand derivative, and we have to find now the left hand derivative at x is equal to 1. So to find out the left hand derivative at x is equal to 1, let's use the given formula. Okay, so our formula for left hand derivative. So this is the second one. We have to find the left hand derivative, and left hand derivative is given by limit h tends to 0, and the formula is f of a minus h. So this is a minus h, a minus h minus f of a upon h. Now we have to find out derivative at x is equal to 1. So a is 1. So this becomes limit h tends to 0, f of 1 minus h minus f of 1 by h. Okay, now let's see what is the function to be used for the left-hand derivative that is a value less than 1. This is the function that has to be used. Now f of 1 minus h becomes 1 minus h the whole square by 4 minus 3 into 1 minus h by 2 plus 13 by 4. So let's put this value here, and what would be the value of f of 1? So f of 1 would be 1 by 4 minus 3 by 2 plus 13 by 4. Let's put in the values first. So this is now equal to limit h tends to 0, f of 1 minus h is 1 minus h the whole square by 4 and minus 3 into 1 minus h by 2 plus the last one is 13 by 4. Okay, so this is 13 by 4. So this is the value of f of 1 minus h. Now f of 1. F of 1 is 1 by 4 minus 3 by 2 plus 13 by 4 upon h. Okay, let's try to simplify this. So now this becomes limit h tends to 0. So limit h tends to 0, I can use a plus b the whole square US. So a square plus b square minus 2ab by 4 minus this is uh, minus 3 by 2 plus 3h by 2 plus 13 by 4. This is minus 1 by 4 plus 3 by 2 minus 13 by 4 upon h. Okay, this has to be uh, this was actually not h. This okay. This was negative h. So this is negative h. So this is negative h. So negative h. Okay, this gets cancelled. 13 by 4, 13 by 4 gets cancelled, and finally we are left with this is limit h tends to 0. So limit h tends to 0, and this is now 1 plus h square minus 2h and plus 3h by 2. Okay, let me write this as 1 by 4 plus h square by 4 minus 2h by 4 plus 3h by 2 minus 1 by 4. This gets cancelled. This is negative h. So this is equal to now limit h tends to 0. Okay, finally we are left with h square minus 2h plus 3h, and if we take the LCM 4, so if we take the LCM 4, it's 6h. So h square minus 2h plus 6h by 4 by negative h. So this is now equal to limit h tends to 0, h square plus 4h by negative 4h. Okay, we can take h common. So limit h tends to 0, h is common, so h plus 4 upon negative 4h, this gets cancelled, and now it's limit h tends to 0, h plus 4 by negative 4. And if we take the limit, so this gives me 0 plus 4 by negative 4, which is equal to negative 1. So left hand derivative is also negative 1. This is our left hand derivative, which is negative 1. Okay, let's move the another part of this question, that is check if the function f of x is differentiable at x is equal to 1. So to check the function is differentiable at x is equal to 1, so here the left hand derivative will compare the values of the left hand derivative. So left hand derivative is equal to right hand derivative. So we can write that here, the function. So we have got the left hand derivative and the right hand derivative. So for this, we can write that left hand derivative is equal to right hand derivative is equal to 1. So that means the function is differentiable at x is equal to 1. So function is differentiable at x is equal to 1. Now we have to find, let's move on to the OR part. Okay, for the OR part, it's asked to find out first order derivative at 2 and the first order derivative at 1. Now we will use the function now to find out the first order derivative differentiation at 2. Now 2 is greater than 1, so that means our function is x minus 3. So I can write this function here is x modulus of x minus 3, and x minus 3 is negative of x minus 3, which becomes 3 minus x, because for this to be positive it has to be negative. And now uh, its differentiation, so differentiation of this is f dash x is equal to differentiation of 3 0 negative 1. So that means mm, differentiation at, if I put 2, there is no x here, so it's simply 1. So differentiation at 2 is 1. Now let's find out the differentiation at negative 1. So negative 1 is less than 0. So our function will be this for negative 1. For x is equal to negative 1, our function is f of x is equal to x squared by 4 minus 3x by 2 plus 13 by 4. Okay, let's find out its first order derivative. So first order derivative is 2x by 4 minus this is 3 by 2. And we have to find out its value at negative 1. So negative 1 is equal to 2 into negative 1 by 4 minus 3 by 2, which is negative 2 by 4 minus 3 by 2, which is negative half. So negative half minus 3 by 2, which is minus 4 by 2, and the value is negative 4. Okay, moving on to the next question. Okay, for question number 37, let's read down the question first. It says that a building contractor undertakes a job to construct 4 flats on a plot along with parking area, and due to strike, the probability of many construction workers not being present for the job is 0.65. And the probability that many are not present and still the work gets completed on time is 0.35. Okay, so workers not present for the job, probability is 0.65, and the workers are not present, and even then the work gets completed, probability of that is 0.35. Now the probability that work will be completed on time when all the workers are present is 0.80. Okay, now it's given that let even represent the event when many workers were not present for the job, and that means the workers not present for the job, that is the even. So let's write down what is given to us. So probability of even, that is the workers not present on the job, is this is 0.65. Okay, now the probability that, let's read out the second one. E2 represent the even when all the workers are present. So E2 is the probability that when all the workers are present, and that would be 1 minus probability of E1, because E1 means, even it's given that it's the even when many workers were not present, and E2 is the even when all the workers were present. So probability of E2 is 1 minus uh, 0.65, which is equal to 0.35. Okay. And that is what is asked in the question, what is the probability that all the workers were present for the job? So we have got our first part. Okay, now let's read out it further. E represent completing the construction work on time, and the probability that construction work will be completed on time when all the workers are present is 0.80. So E is the probability. So E is the event. So E is the event that construction work is completed on time. So E is the event for construction work that is completed on time. All right. So what is the probability that all the workers are present for the job? So all the workers are present for the job is probability of E2. And what is the probability that the construction work will be completed on time? So we have to find out the probability of, this is the second one, probability that the construction work is completed on time. So now the construction work is completed in two times, when all the workers are present and when all the workers are not present. So when all the workers are present, many workers were not present is E1. So probability that construction work is completed is when all the workers are not present, and the construction work is completed when all the workers are not present. So the construction work is completed in two cases: when all the workers are not present, and this is when the construction work, when all the workers are not present and the construction work is completed. Okay, second case was when all the workers were present. So that is probability of E2. And now construction work is completed when all the workers are present. So this is how the construction work is completed. Now probability of E1 is, this is 0.65. Now probability that all the workers are not present is 0.65, and probability that construction work is completed when all the workers are not present. So probability that construction work is completed on time when all the workers are not present and still the work gets completed is 0.35. So this one is 0.35. Now, because probability that all the workers are present is 0.35, and construction work is completed when all the workers are present. So construction work is completed when all the workers are present is 0.80. So this is 0.80. All right. So let's try to simplify this. So 0.65 into 0.35. So 0.65 into 0.35 is equal to, this is 0.2275. So 0.2275 plus, this is 0.35 into 0.80. So 0.35 into 0.80 is equal to zero point 0.2. So this is 0.28, which is equal to, so we have to add 0.2275 in 0.28, which gives me 0.5075. So this is equal to 0.5075, and if we round it out to two decimal places, this will be 0.51. Okay, now third one, what is the probability that many workers were not present and given that construction work is completed on time? So what we have to find out here is that we have to find the probability when, so what is given is the construction is the construction work is completed on time is given. So that means this is the condition: construction work is completed on time and many workers are not present. Many workers are not present is E1. So we have to find E1 by E. So this is the probability that we have to find out, E1 by E. Okay. So E1 by E, this is probability of E1, E1 into probability of construction work is completed when all the workers are not present, upon, let's, so this is E by E1 plus. The second event was when all the workers are present. And what is the probability that construction work is completed when all the workers are present? Okay, so probability of E And this is 0.2275. So this is 0.2275 divided by point probability of E1 into probability of E by E1. This is 1 again, 0.2275 plus probability of E2 into probability of E by E2 is 0.28. So this is 0.28. Okay, 0.2275 upon, if I add them, this comes up to 0.5075. And if I divide them, this is 2275 divided by 5075. And if I 2275, okay, 2275, that has to be divided by 5075, which is equal to 0.448. So this comes out to be 0.448, and up to two decimal places, this should be 0.45. Okay, now the OR part, the third B part. What is the probability that all the workers were present, that the construction job was completed on time? So construction job was completed on time and all the workers were present is probability E2. So this is what we have to find out. Okay, probability of E2 by E, and that is probability of E2 into probability of E by E2 upon probability of E1 into probability of E by E1 plus probability of E2 into probability of E by E2. Okay, let's write down this. So probability of E2 into this is 0.28, and we have already added this. This is 0.5075, so 0.5075, which gives me, this is now, so probability of E2 into probability of E by E2 is 0.28, and okay, so let's simplify this. This is 0.35 into zero point 0.8, which is 0.28, and I can write this one as 0.51. So this gives me 28 divided by 51. So 28 divided by 51 gives me 0.54. So this is 0.54. So 0.549 is the answer, and if you round off, this will be 0.55. So 0.55 is the probability. Okay, for question number 38, it's given that Suzanne's father wants to construct a rectangular garden using a brick wall. And this is a brick wall on one side of the garden. So on one side, it's a brick wall and wire fencing for the other three sides. So this is a wire fencing. This is the brick wall. So one side of the garden will have this, let's say this is the garden, rectangular garden. So this would be a brick wall and the other three walls would be the wire fencing. This will have the fencing of the wire. Now he has 200 meters of fencing wire. Based on the above information, answer the following questions. Let X meter denotes the length of one side of the garden perpendicular to the brick wall, and Y meter denotes the length of the side parallel to the brick wall. Determine the relation representing the total length of fencing wire and also write A of x, that is the area of the garden. Okay, so let's draw a picture first. Let's say this is a brick wall. This is a rectangular garden. Let there be a brick wall. So this is a brick wall. Okay, now what is given to us is that x meter denotes the length of one side of the garden perpendicular to the brick wall. So let me take this. This is the length side perpendicular to the brick wall. Let this be x. Okay, so if this is x, this is also x because this is a rectangular garden. Now y meter denotes the length of the side parallel to the brick wall. So parallel to the brick wall is this side and its length is y. Determine the relation representing the total length of fencing wire. The fencing wire is the three sides, 1, 2, and 3. This is the fencing wire. We have to find out the total length of denote the length of the side. Determine the relation representing the total length of fencing wire. Total length of fencing wire. So total length of fencing wire according to the figure is 2x plus y, and total length of the fencing wire, but it's given that the total length of the fencing wire is 200 meters, so this is a relation 2x plus y is equal to 200 meter. This is the total length of the fencing wire, and this is, let's say, part 1's answer. Now we have also to write the area in terms of x. So area in terms of x, we know that the area is given by length into breadth. So area in terms of x, and area is equal to x into y, length into breadth. And now this is x and we can get a y here. So this will give me y. So y is equal to 200 minus 2x, and okay, so I can write here this is 200 minus 2x, and I can take 2 common. So this is 2x into 100 minus x. This is the area in terms of x. X into 200 minus x, length into breadth. Okay, now next question. The next part is asked, determine the maximum value of a of x. So for maximum value of a of x, r a of x is equal to this. So let me just open this. This is 200x minus 2x squared. Now for maximum value of a dash x should be equal to 0. So this its differentiation would be 200 minus 4x is equal to 0, which gives me negative 4x is equal to negative 200, and x is equal to 50. So that gives me x is equal to 50. Now let's check whether at this value the area is maximum or not. So let's find out the second order derivative. Write down the second order derivative. You are going to use the second order derivative test. So first order derivative was this, and the second order derivative would be negative 4. So that means at x, when x was 50, it's negative 4, which is less than 0. So that means when x is equal to 50, area is, this is maximum. Okay, so determine the maximum value, and we have to find the maximum value of the x. So the maximum value of the x is at 50. So this is 200 into 50 minus 2 into square of 50. So 5 to that is 10,000 minus 50 squared is 2,500. 25 into 2 is 50. So this is 5,000 and this is 5,000 meter square is the maximum value of the area. Okay, now, so this finishes. Okay, all about, that was all asked in this question. And with this, we are done with this set. So do like, share, and subscribe. Thank you for watching.